Hello everyone, this is MURUGAVEL from Information Technology, pursuing in a PhD College of Technology. So today they're giving me a problem statement. I have to explain through this video. Hopefully you learn some insightful information from this. If so, do like. So let's see the problem statement. Find the minimum and maximum number of nodes between the critical points. A critical point in a linked list is defined as either a local maxima or local minima. A node is a local maxima if the current node has a value strictly greater than its previous and next node. So as you see here, the local maxima, we say a node is said to be local maxima if the current node value is strictly greater than its neighbors. As like local minima, if the value is strictly smaller than its neighbor. So if either of these two conditions satisfy, we say a node comes under critical point. Note that the node can only be a local maxima, local minima if there exist both previous node and next node. So from this we conclude that first node and last node doesn't come under this critical point. So what we have to return is return an array of length 2 containing minimum and maximum distance. Minimum distance is the minimum distance between any two distinct critical points. Maximum distance between any two distinct critical points comes under maximum distance. So if there is no such, we have to return -1 and -1. So let me put it in a simple term by considering the test cases. So they given me 5 3 1 2 5 1 2. So 7 nodes is there. So if you see the explanation part, so out of 7 nodes, 3 nodes, which is 1 5 1. So these 3 comes under the critical point. For example, the third node of value 1, if you see its neighbor, which is 3 1, which both are greater than node 1. So we say that it comes under local minima. And also the next line they given like a fifth node of fifth index, that is also comes under local maxima because the neighbor value is smaller than the current node. And at last is a sixth node. They are considering index in a one based. The neighbors also very greater than the current node. They also find distance, that is 6 minus 5, 6 minus 3. So this 6, 5, 3 are indexes. They are considering indexes, not their values. So out of which is minimum and maximum they taken, and the output is array also containing that minimum and the maximum distance. So actually it is a simple question. Let me explain first about my algorithm. My algorithm consists of 2 steps. Step 1 is finding all its critical point. Consider the following linked list. First, I'm going to find its critical points, that is 1, 5, 3. And I'm going to take its indexes, not its value. I'm taking its corresponding indexes and I'm storing it in an array. So this is my first step of my algorithm. So let's move to second step, which is finding minimum and the maximum distance. Consider array, which we already stored indices value 3, 5, 6. So I'm going to find its minimum and maximum distance. So like you see, 6 minus 5 gives 1, 6 minus 3 gives 3. So you have a thinking like how we can achieve this. You might think it might comes under n square complexity, but at last I explained you in big O of n complexity. So there is a tricky part in it. So this step 2 I explain in further upcoming seconds. So before I'm showing my code, I show my dry run so that you can write the algorithm by yourself. So this is my dry run part. So consider there is a linked list along with indexes also I mentioned, and array also mentioned, where I going to store the critical point indexes. So currently we are standing at first indexes, As I already question mentioned that first and the last element doesn't have neighbors, right? On its both side there is one part of a neighbor is missing. So we can't say first and last element comes under critical point. So I'm moving to next point, which is 3. So 3, and I'm comparing with its neighbor, which is 5 and 1. So both are here conflicting because 5 is greater than 3, 1 is smaller than 3. So I can't conclude this one as either a local maxima or local minima. So I move to next index, which is 1. So I'm considering its neighbor, 3 and 2. So 3 is greater than 1 and 2 also greater than 1. So I can say this comes under local minima because it's strictly smaller than its neighbor. So I take this index, which is 3, and put it in my array. And now I move to next index, which is 2. And I am considering its neighbor, which is 1 and 5. 1 is smaller than 2, 5 is greater than 2. So I can't comes this one as a critical point. So now just I move to next index, which is 5. And I'm seeing this neighbor, both are smaller than current element. So I say the current node is a local maxima. And I take corresponding 5 and put it in my array. And now I move to next index, which is 1. And I am considering its neighbor. Okay, all the neighbor values is greater than the current value. So I take 6 and put it in my array. So my first part of algorithm is gets over. Even when we move to next index, which is our base case, right? Because last index doesn't comes under our critical point. So let me move to my second step, which is finding minimum and maximum distance. So how we can achieve this? So first we'll discuss maximum distance. So as you see here, our array is in ascending order. Not only this time, every time our array will be in the shorted or ascending order. This is because we are moving the pointer from left to right in the one based indexing. So always the value which is we are adding currently now will be greater than its previous value. So that only the array is always in sorted or ascending order. And also the first value of that index is very minimal and the last value of that array have the very highest value. If we subtract very highest value with the very smallest value, we get the maximum distance. So that is the concept here. So I am subtracting 6 minus 3, I get 3, which is our maximum distance. We can compute this in big O of 1 complexity itself. So now let's see its minimum distance, how we can calculate its minimum distance. This is not possible in the complexity of big O of 1, yeah, because there is no uniformity here. There is a 3 5 3 5 difference is 2, but 5 6 difference is 1. So there is no uniformity here, right? So we can't conclude this with the big O of 1 complexity itself. So I have to find all its possible neighbor, subtract it and find the distance, out of which is minimum I have to take. Here you see the array have 3 5 6 value, right? So I am subtracting 5 minus 3, 6 minus 5, not 6 minus 3. I think you know about this. If we subtract only with its neighbor, we get the minimum distance. If we subtract the value with the element which is greater than neighbor, definitely we're going to get a distance with this maximum only. So we're not able to get a distance with minimum. So that only we are taking its neighbor. So here I got like 2 and 1, out of which 1 is minimum, so I take that one. So now our result array contain 1 and 3, where 1 is the minimum distance that we find out by subtracting its neighbor, right? We find out all its possible combination and find out with the minimum value distance. And next is 3. which is our maximum distance, we find out in the big O of 1 complexity itself. So this is the thing we have to written. So now let's see the code. So this part of code involves in the step 1 of my algorithm. I'm given my break condition, or we say it as a loop condition. Current dot next not equal to null. That is, if we standing at a last index, that is our base case. Until then, we can execute this while loop. And in my first line of while loop, I given on the if statement, control statement, of which two condition I have given. More specifically, local maxima, local minima. See that current value, if it is greater than previous dot value, and current value is greater than current dot next value. If this condition satisfy, the current node that we are standing is local maxima, or local minima condition also I have specified here. So either of this condition satisfy, we can add that point or that position into our critical points. Here position specify the index, not that particular value. So once we add in, we have to change the position, that is previous change to current position, and our current position change to next position, and position which is the index value that we are incrementing, so that index always it increment, right? Either the condition index value is 1 based, position that is initialized with 1 also. So now let's move on to step 2 of our code. First, let me explain how we can find maximum distance. So it is a simple algorithm. So we are getting, you see here, critical points dot size -1, which is our last index, and critical points dot get 0, which is our first index. We are both subtracting these two, and we are getting the result, which is we put it in a max distance. And for minimum distance, we are subtracting corresponding neighbor, right? So it comes under big O of n complexity. We are using for loop for finding its neighbor. So specifically see this point, that is critical points dot get I, which is currently we are standing, minus critical points dot get I minus 1, which is our neighbor. We are subtracting these two and comparing either it is smaller than already existed minimum distance, as like we are comparing. And also you see minimum distance is initialized with the integer dot max value. So always first time the condition satisfy. And at last we return our array with minimum distance and a maximum distance. So this is the code actually. It is very simple code, and I think my dry run will able to understand you how this all logic works. Okay, so let me run the code in examly portal that they have provided. As you see here, all the test cases get passed. So actually this is very simple question that you can see, and its space complexity is big O of n, and its time complexity is big O of n. Hopefully through this video you learned something. If so, do like. Thank you.